Now in this module we will investigate what happens when SELINUX denies access to objects, and how we can check that by using commands like sealert, journalctl, audit search and audit report. But let's first discuss what a denial actually is. A denial is generated anytime a service or application is denied access by SELINUX. Whenever that happens, the denial is cached in the access vector cache, or AVC. So we could speak of AVC denials. Now keep in mind that targeted policies only protect those environments that run in confined domains like HTTPD, NAMED, SSHD and others. Other entities that run in an unconfined domain are not protected by SELINUX. So processes that are unconfined only run into the DAC or discretionary access control rules for read, write and execute. Of course, we've already checked the audit log to search for denials. Where the denials are stored depends on your system services. If the audit daemon is enabled and running, then they're stored in the varlog audit log file. And if auditd is not running and our syslogd is on, then they will be stored in varlog messages. And when both services are running, the logging will also go to both of the above files. Now the nice thing is that AVC messages are logged or printed even when the system is in permissive mode. So you can test what will happen if SELINUX were enforcing. So in fact, they're just event messages. The actual system calls are only actively denied when SELINUX is enforcing. Now let's demonstrate that with an example. So I'm logged into my Linux machine and check that SELINUX is in permissive mode using getenforce. What I did is I changed the port for HTTPD in its config file to 9594, as you can see here. Now we restart HTTPD and we do not get any errors. So we check and see that HTTPD is running perfectly fine and listens to the port that we configured. Now the simplest way of checking whether there are any denials in the audit file, we can use grep and search for the port that HTTPD is using. And we see that the type of message is AVC and the event is a denial, but since we're in permissive mode, we're not really denied. A better way of checking would be using the audit search command to investigate the audit log. And this command has quite a few options. We're not going to discuss all the options. Please have a look at the menu page later on. For us at this point, we're interested in what happened to HTTPD, so we filter on the HTTPD command, like this. So this time we see a little bit more. We see that next to the AVC fields, we also see the syscall field. And it tells us that the success equals yes. So this means that it wasn't blocked based upon connecting to an unreserved port. So it's simply allowed, even though AVC says denied. Let's change to enforcing and restart the HTTPD daemon. So we set enforce to 1, run systemctl, restart HTTPD, and as expected we now get an error message. So let's run audit search once more and let's concentrate on the last 2 lines. And we see that the important field that has changed here is the system call success field, which is now set to no, because HTTPD is not allowed to connect to an unreserved port. And yet another tool that will tell you about success and about problems is the audit report command. Audit report will simply summarize things without a lot of detail. Like with other commands, audit report has many options. Just a few for us here. The -A option gives you just a list of the AVC type denials. And of course we see that our unreserved port type was denied, but it's not very specific. The -E option lists events that happened and whether they were successful or not. And probably this was our HTTPD start, which was not successful a couple of times, where others were successful. And for the summary of all summaries, we simply do not use any options. We see summaries of many things like successful and failed logins, the number of AVCs and a lot more, including the total number of events. Now the next command we want to check is SELINUX. And SELINUX is a command that is provided by the SE Troubleshoot server package, which is, as you may remember from the setup module, not installed by default. So you have to install it before you can use it, obviously. Another interesting thing is that the logging is not done by SELINUX itself, but by SE Troubleshoot. And it logs to the messages file and not to the audit log. So all I need to do is to grep for the SELINUX entries in the messages file. Now when I filter on SELINUX, it advises me to run the command with a hexadecimal lookup ID that will give me information on the denial. So let's just have a look at that. If we copy and paste that command, we recognize this as the output that we got from audit search. Remember? So we see the syscall entry and the AVC lines with the same information that we saw earlier. And obviously, because we run in permissive mode, success equals yes, but the AVC shows the denial. And finally, we want to have some real proper troubleshoot advice from journalctl, which is, as you know, a regular Linux command, and which you can use to get information from particular services in our system. And in this case, we want to have the type SE Troubleshoot. But before we do that, let's check the time, because we don't want to have too much information. So it's 9 something, and we restart the web server once more. Mind you, we are running in an enforcing mode at the moment, and so we get an error message. Now, so as agreed, we will use the SE Troubleshoot type to filter out messages, and of course we want to have all messages after 9 o'clock. Now this is really cool because it gives us some options to fix the problem. First, we see it advises us to use SE manage to permanently change the policy as we did in a previous module. The second option is to use set Sabul. Guess what? We'll deal with that in the next module. And if we think that it should work and we consider this to be a bug, we should report that. But if all else fails, we have a final suggestion, which says that if we think that HTTPD should be able to bind to an unreserved port, then we should run the audit to allow command. Now there's a reason why this is the last resort. Now let's have a look at that. This is something to be very careful with, because you actually instruct SELINUX to build a local policy module based upon a denial, and you might open up more than you bargained for. You should first try and fix the problem in a different way by changing the label, using change context or SE manage, but not audit to allow. So this is really the last thing you should do. But for demonstration purposes, we are going to do it. So what this command does is it literally takes the denial and transforms it into an allow and creates a module of it. And when you install the module, this will no longer be denied. And after it's been created, we can install the module, and now we will be able to start our web server again. But again, this should not be your first option. So to disable it, you could use SE module -d and then remove it using -r. Finally, please have a look at these commands that we used, the important ones in this module.